The least squares line for the relationship between the height and weight for supermodels is given as y hat is equal to 3.88x minus 152. Find the 99% confidence interval for an average model's weight given that the model was 73 inches tall. Okay, so we have some nice summary data here at the bottom, and we notice that I've underlined the phrase confidence interval for an average model's weight. So we're dealing with the confidence interval for an average model's weight, not for a specific model's weight. So we're going to see later that something called a prediction interval is conducted when you're looking for the specific model's weight. Here we're looking for the average model's weight, so it's just a regular confidence interval. Okay, so let's start with our first step. Our first step is to normally record the data. Well, the data is given to us nicely, but we're going to use the first step to do one other thing, which is to get our point estimator. So first let's identify the fact that alpha here is 1%. And I know alpha is 1% or 0.01 because the confidence level is 99. Now from there I have the model itself, y hat is equal to, it says 3.88x minus 152. Okay, so that's the model that's given to us. Now we're going to plug in for x 3.88 times 73, that's our x value, minus 152. And this will give us our y hat value, which is going to be important in our problem. Okay, so I'll have 3.88 times 73 minus 152. And when I do that, I get 131.24. Okay, let's save that for later. We're going to use that in the final step of the problem, but that's our point estimator. So that's what we would think is our estimate of the average height for a woman who is, the average weight for a woman who is 73 inches tall. So this is the average weight that we would expect for a woman who's 73 inches tall. But remember, that's a point estimator. We want to create an interval estimator, so we're going to go on to finish our remaining 3 steps. Our next step is the T alpha divided by 2 step, get our table value. Now in this case, the alpha divided by 2 will be 0.01 divided in half, which is 0.005. And we're going to use degrees of freedom n minus 2. So here our n is 9. We're going to take away 2 from that, we'll end up with 7. All right, let's go to our table now. Look up in the 0.005 column, 7 degrees of freedom, and that will give us our critical table value. Okay, so we're looking for 0.005 with 7 degrees of freedom. So 0.005 down to 7 degrees of freedom, we find the answer 3.499. Okay, so our table value is 3.499, 3.499. And from there, we're going to use that value in our next step, which is the margin of error step. So let's go take that and plug it in for our margin of error. Now, our margin of error has the following formula again. It's T alpha divided by 2 times S times the square root of 1 over n plus a fraction. The fraction is xp, the predictor x value, minus x bar, quantity squared, all divided by the sum of squares for the x's. Okay, so that's our formula. Now let's plug in our values for that particular formula. So our T alpha divided by 2 is 3.499. Our S value in this problem is given to us. They tell us that S is 4.8789, so 4.8789. And we're going to have that all multiplied by the square root of 1 over n. Now our n in this case is 9, so it's going to be 1/9 plus a parentheses, which will consist of the x predictor value, which was 73, minus the x bar value, which is 70.2 repeating, so 70.2 repeating. And then it'll all be divided by our sum of squares for x's, which is 19.0, looks like 5 repeating. Okay, I'm just going to write that out a little neater over here because it's a little hard to see there on the edge of the screen. So let's go ahead and write it out over here. It'll be 3.499 times 4.8789 times the square root of 1/9 plus parentheses 73 minus 70.2 repeating, quantity squared, divided by the sum of squares for x's, which is 19.05 repeating. Okay, now let's see what all that works out to be in our calculator. So we're going to have 3.499 times 4.8789 times the square root of 1 divided by 9 plus parentheses 73 minus 70.2 repeating. Close up the parentheses, hit square, divided by 19.05 repeating. Okay, close all that up and enter that in your calculator and get the value 12.263. So 12.263 dot, right? All right, I'm gonna store that in my calculator because that's our margin of error. I'll store it in there for X. And so our next step is, once we have this value, we're gonna add and subtract it to and from our point estimator. So our point estimator, remember, is y hat that we did in step 1. So it'll be y hat minus e, y hat plus e. Okay, so in our case, the answer is 131.24 minus 12.263, then 131.24 plus 12.263. All right, and let's see what that ends up giving us here. So we'll have 131.24 minus that value that I stored in my calculator, and then the same thing, but plus the value. So we end up with 118.98, let's say, up to 143.50. All right, and so our interpretation is pretty simple. We are 99% confident. So we are 99% confident that the true average weight for models who stand 73 inches tall is between 118.98 and 143.50 pounds. And that's it. That's our solution.